Hi guys! Today in this video we will learn about inverse functions. An inverse function only exists when the function is one-to-one. And how do we check whether a function is one-to-one or not? Well, there are two ways to check, and I will show you in the video today. So the first method is what we call as the graphical approach. In this graphical approach, we have to sketch the graph, no matter how does the graph looks like. After that, we have to do a horizontal line test. And what does horizontal line test means? It means that we have to draw one straight line horizontally and see how many points does it cut. For this example, it cuts only at 1 point, so that means it's a one-to-one function. But if, let's say, the graph cuts at 2 points, for example like this, then the function is not one-to-one. So when it's one-to-one function, that means the inverse exists. But if it's not one-to-one, that means the inverse function does not exist. The other method is algebraic method. And how to show it's a one-to-one function algebraically is we have to start by using this formula, where the formula is fx1 equal to fx2. What does this mean? It simply means replacing the variable x1 into this x. Write it on the left side. And then next, just replacing the variable x2 into this x and write it on the right side. Simplify them, and lastly, what you want to show is you want the final answer to be x1 equal to x2. And if you have managed to show this, then it's a one-to-one function, which means that the inverse function exists. But if, let's say, after you have showed this and then you cannot show that x1 is equal to x2, that means it is not one-to-one function, and this implies that the inverse function does not exist. Now, let's take a look at this example A. Try to show that the function is one-to-one graphically. To use the graphical approach, of course, first thing that you need to have is you need to draw the graph. And to draw the graph of a linear function, well, it's pretty easy. What you need to know is just the 2 points, x equal to 0 and y equal to 0. So when x is equal to 0 here, the answer of y is 2. And when y is equal to 0, you get x is equal to negative 2 over 3. Draw the axis, y and x, plot the points where we have the first point as 0, 2 and the second point as negative 2 over 3, 0. This is the second point and the first point is 0, 2. Once we have these 2 points, just draw a straight line as long as it should be, because there is no domain given, so that means the graph goes to infinity and negative infinity, and this is your graph. Now, remember that to use this graphical method, you need to draw this horizontal line test. And what does that mean? It just simply means drawing a straight line horizontally and see how many points does this horizontal line cuts. If you can see here clearly that this line only cuts at 1 point. Well, if I try to move my horizontal line to the other places, for example here or here, I will still always cut at 1 point. So that means it is a one-to-one function. So we can write our conclusion something like this. And what do we know if it's a one-to-one function? We know that the inverse function must exist. Now, let me show you the algebraic method. Well, what was the algebraic method? It's letting fx1 equal to fx2. Let's start with that. Write fx1 equal to fx2 and then just replacing the x with x1. Write it on the left side, and then on the right side it should be x2. Replacing the x with x2 on the right side. Next, we must simplify until we get only x1 on the left side. Make x1 as the subject. I can see that there is plus 2 here, so to eliminate plus 2, I can just bring this to the right side to be minus 2. So 2 minus 2 is just 0, and you're left only with 3 on both sides and x1 and x2 next to it. After that, remember, we just want to let x1 to be the subject. That means we have to eliminate this number 3. To eliminate number 3 means we have to divide both of these with 3. That means we are left only with x1 equal to x2. Once we get x1 equal to x2, what does that mean? It simply means that it's a one-to-one function. Thus, it implies that the inverse function exists. So write your conclusion here. Now, the next part of the question wants us to find the inverse function. To find the inverse function, we must always start with this formula. F inverse is equal to x. So, to find the inverse function, let us let this to be equal to y. For example, okay, let me write it here. This one is equal to y. So that means we are actually finding fy equal to x. Because what we want is f inverse equal to y. Okay? Since we have let f inverse equal to y, so we can simply change this f inverse to be y. And what we need to find next is just fy equal to x. We already know what is the function of f in terms of x. We just need to change the x to be y. And then equate it to x. Now, let's try this out. Copy the function 3x, change the x to be y, and then plus 2. On the right side, it's equal to x. And what do we want to find? We want to find f inverse, which is equal to y. So that means we want y to be the subject. Bring everything to the right side and just leave only y on the left side. Like this. Once we have gotten our y as the subject, we just need to rewrite this as f inverse equal to y, which is x minus 2 over 3. And you're done. This is an example for a linear function. What about if the function is quadratic? Let's take a look at this example B. Show that the following function is one-to-one. So, remember that I've mentioned before, there are two methods. The first method is graphical. The next one is algebraic. Let's look at graphical first. And for graphical method, we must always sketch the graph. What's the step to sketch this graph? Don't worry, the step is just easy. Step 1 is looking at the shape. Look at the value of a, which is the coefficient of this x squared. A is equal to -1, and -1 is less than 0. That means the shape is this set graph. The second step is finding the maximum point. And to find the maximum point, you have to memorize this formula, -b over 2a. And what's the b in this case? There is no b because there's no x variable. So -0 is just 0 divided with everything is 0. Next, to find the coordinate, we need to know what is the partner of 0, the y coordinate for when x is 0. We just need to replace x with 0, -0 squared plus 5, you get 5. So that means the coordinate is 0, 5. Now we can sketch the graph. 0,5 is situated on the y-axis here, and then the graph looks like a sad graph like this. Okay, not forgetting that we must check the domain given in this question. If there is no domain given, that means the graph will exist from negative infinity to infinity of the x-axis. But for this question, the domain is given as follows, which is x greater than and equal to 0. That means the graph only exists on the right side of x. So what do we have to do with the left side graph? We have to erase it. And since there's an equal sign here, that means the dots here will also be a dense circle. Now, as you can see, it does intersect with this x-axis. What is that value? You can simply find it by finding y equal to 0. Negative x squared plus 5 is equal to 0. So what is x? X is positive and negative 5. And since the graph only exists greater than or equal to 0, so this intersection is at 5. Now, the question is asking about whether it's a one-to-one function or not. Remember, to check whether it's a one-to-one function or not, what we have to do is to check this horizontal line test. After we have obtained the correct graph, we must draw this horizontal line. Draw the horizontal line and see how many points does it cut. Well, here it cuts at only 1 point. So that means that it is a one-to-one function. But what about the other points? Well, you can try to move your ruler here and see how many points does the graph cut if we draw our horizontal line. And you can see that it will always cut at 1 point. So it is a one-to-one function. And then write your conclusion. The horizontal line cuts the graph at only 1 point. Thus, fx is one-to-one. Now, let's look at the algebraic approach. Remember what does algebraic method is? Algebraic method means that we have to let fx1 equal to fx2. To start by writing that down, but wait a minute, I have written down the wrong function. The function is p, so I could not write f, I must write p. Same thing here, should be px. Okay, sorry about that. Next, just replacing this x, x1 on the left side as follows. Next, on the right side, replacing x with x2. Okay, to simplify this, you can bring plus 5 to the right side. So 5 minus 5 is 0. And then you're left with x1 squared on the left side, x2 squared on the right side, but with negative in front of each of them. So remember that we must make x1 to be the subject. This means that we have to eliminate this negative, and to eliminate that negative, we can simply divide everything with negative. So this is actually equivalent. Next, whenever you want to eliminate this square, you have to write a plus minus and put a square root. But whenever square root meets square, it will cancel off. So this means on the right side, you're only left with plus minus x2. But hold on a second. Look at the domain given. The domain given here is x greater than and equal to 0. But now, positive and negative x2. So the negative x2 will not exist in this function p. That means we have to eliminate that negative x2 and only choose the positive x2. Thus, x1 is equal to x2. And this means that the function is a one-to-one function. And what does this imply? It implies that the inverse function exists. Now, let's find the inverse function. Remember that to find the inverse function, you must always start with the formula of f inverse equal to x. Next, you are going to let this f inverse to be y. Why do we let it to be y? So that it's easier for you to solve. Now, f inverse has been let to be y, and the formula has been changed to this one. But remember, we are not dealing with f right now, we are dealing with p. So just change f to be p. Okay, now this is just py. We know what is the function for px. So to find py means that we just have to replace this x to be y. So it will be negative y squared plus 5. Write it here. After that, on the right side, it's equal to x. Okay, remember we are finding the p inverse, which is equal to y. So this means we want y to be the subject. Bring everything else to the right side. So here, you'll have x minus 5, and then leaving only negative y squared on the left side. After that, bring this negative to the right side means that you have to divide everything with negative. The sign on the right side will change. And next is putting the square root because we want to eliminate the square on the left side. In front of square root, there must be a plus minus. And then let me rewrite this to be 5 minus x. One thing that you need to note that is the domain of function p is equal to the range of p inverse. The range of p is equal to the domain of p inverse. So it's just the opposite of the inverse functions. Well, why am I stating this now? That's because the domain for function p is given. The domain for function p is given as starting from 0 to infinity. Means that there's no negative value. So this means that the range for the function p inverse is also the same, which is starting from 0 until infinity. And as we can see here that our y is actually our p inverse function. So this means that our range for p inverse must also be starting from 0 and to infinity. That means there's no negative value here. But if we write a negative value outside of the square root, that means the range will be until the negative infinity, which is wrong in this case. So that's why we have to only choose the positive surd or positive square root. So we should write our conclusion as, since the domain of p is x greater than or equal to 0, then p inverse is equal to square root of 5 minus x. And we are done solving these questions. Thank you for watching.